close your eyes. Take a moment to imagine absolute nothingness. Strip away the stars, erase the galaxies, and remove every single atom until you are left with a cold, infinite, and silent dark void. In our daily lives, and even in classical physics, we think of a vacuum as simply an empty box, a container devoid of matter, waiting to be filled. But that picture is wrong. If you were to zoom in way in, past the molecules and into the fabric of space itself, you'd find that nothing is actually throwing a massive, invisible party. Welcome to the quantum vacuum. According to quantum field theory, the universe isn't made of tiny, solid billiard balls. Fundamentally, it's made of fields that stretch across everything. Think of space like a vast ocean. Even when there are no big waves, no particles, the surface is never truly still. It is constantly jittery with tiny, microscopic ripples.
Behind every question lies discovery. I'm Saluna, and this is SciCurious, where we uncover the science shaping our world.
These are quantum fluctuations. In empty space, energy levels are constantly boiling, driven by the Heisenberg uncertainty principle. It basically states that nature refuses to be perfectly pinned down. You cannot have zero energy for zero time. The universe is allowed to briefly borrow energy from nowhere as long as it pays it back almost instantly. This frantic borrowing and repaying is happening everywhere, all the time. These ripples create virtual particles. They pop into existence in pairs, matter and antimatter, high-five for a fraction of a nanosecond, and then annihilate each other in a flash of energy. It sounds like science fiction, or maybe a glitch in the simulation, but this zero-point energy is mathematically real. It's the hum of the universe's engine. Calculations suggest that if you added up all this jittery energy, even the emptiest corner of the galaxy would be incredibly heavy, densely packed with raw power. But isn't this just theory? No. In 1948, Dutch physicist Hendrik Casimir proposed a way to prove it. He predicted that if you put two uncharged metal plates incredibly close together in a vacuum, something spooky would happen. He said they would be pushed together by an invisible force. Not gravity, not magnetism, but the force of the vacuum itself. Here is why. The gap between the plates is so small that only small quantum waves can fit inside. But outside, all sizes of waves can exist. This creates a pressure difference. There is literally more boiling energy pushing from the outside than from the inside. The universe creates a physical force from nothing, effectively trying to crush the plates together. This energy might be the key to the biggest mystery in cosmology: dark energy. We know the universe is expanding faster and faster, pushed by an unknown pressure. Vacuum energy is the prime suspect. However, there is a catch. Our calculations for vacuum energy are way bigger than the dark energy we actually observe. It's known as the cosmological constant problem, the worst prediction in physics history. Despite the mystery, the potential is limitless. If we could ever figure out how to tap into this boiling energy, we have a fuel source that exists everywhere at once, infinite energy from empty space. So, the next time you feel like you're doing nothing, just remember, the empty space inside your very atoms is boiling with activity, alive with the most fundamental dance in the universe. Is nothing actually everything? And if you could harness this power, where would you go? Let us know in the comments below, and thanks for watching.
There's always more to discover. I'm Selu, and this has been SciCurious. Stay curious, and I'll see you in the next wonder.